So in this session, we will see some basic relationship between pixels. Neighbors of a pixel. Now when I say that if this is a pixel, okay, for example, if this is a pixel, so pixel P, okay, if this is a pixel P having coordinates values x, comma, y, okay. So this pixel P has two horizontal and two vertical neighbors. Yes or no? This is true? Yeah, this is true. So if this is x and y, then what will be this? This will be x minus 1 y, right? And this will be x plus 1 y. Similarly for this will be x comma y minus 1 and this is x comma y plus 1. Okay, because if you remember in the previous lecture, I have in the beginning first or second lecture I told you it will be like this is 0 comma 0, this is your x and this is your y. Okay, that we have seen. So for any given pixel P having coordinates x and y, there will be two vertical and two horizontal neighbors. Okay, so these two horizontal and two vertical neighbors, okay, are called four neighbors of pixel P. Okay, and it is always represented by N4P. So N4P means four neighbors of pixel P. Okay, so each pixel is a unit distance from x and y. So the distance between these two pixels is unit distance. Okay, it is equal distance between this and between any two pixels. If x and y is on the border, okay, suppose this is the image, okay, if this is the image and if the pixel is on a border, so what will happen? Pixel on the border, minimum one neighbor of pixel P, okay, minimum one neighbor of pixel P will be outside the image. Okay, so whenever you want to define a border, okay, you have to take care of this, right? Whenever at least minimum one neighbor. Why I'm saying minimum one neighbor? If you take this pixel corner, okay, so how many neighbors will be outside? One and two, right? And two will be on the image. Okay, two will be on the image. But if I take the image, if I take the pixel here, then you will have one pixel inside, second, third, and fourth will be outside. So minimum one pixel will not be in the image. The four diagonal neighbors of P are NDP. Now we have seen N4P, that is four neighbors of the two horizontal and two vertical. So suppose this is a pixel P, I said these are two horizontal and two verticals. But there are diagonal pixels also. So 1, 2, 3, 4. So there are four diagonal neighbors for pixel P. So that is represented by ND. Okay, diagonal neighbors of pixel P. And that will be represented, what I said, this is x comma y. So this is what? X comma y minus 1. This is x comma y plus 1. Okay, this is what? X minus 1 y. This is x plus 1 y. So this will be what? X minus 1 y minus 1, right? Similarly, this will be x plus 1 y plus 1 and so on. So you will get these four diagonal neighbors. So now if I add N4P plus NDP, what I should get? 4 plus 4, 8. So it is represented by N8P. So any given pixel will always have 8 neighbors, 4 diagonal, 2 vertical and 2 horizontal. Now why we are studying this? Okay, because we want to talk about the connectivity between the pixels. And why connectivity of the pixel is important? If I want to find out whether there is a edge in the image, okay, whether there is a border in the image, then we have to use all these concepts. Okay, so connectivity between pixels is very important because it is used in establishing boundaries of objects and components of regions in an image. So generally in higher level algorithms we use this. Okay, so two pixels are connected Okay, if there is one image, okay, if there is an image, and if I take any two pixels, okay, so pixel P and Q suppose. So can I say always Q will be neighbor of P only because it's just adjacent to P? Okay, I repeat again. Can I say always that Q is a neighbor of P only because it is adjacent to P? No. Okay, why no? Because suppose there is one image having water bodies and land, suppose. Okay, this is water, this is land. Okay, so the pixel on this edge actually belongs to water, and the immediate next neighbor of this pixel will belong to what? Land, right? So can I say that this pixel, land pixel, is a neighbor of this edge pixel? No. Why? Because the properties are totally different. So even if physically they are near to each other or adjacent to each other, they may not be connected. Why? Because the properties are totally different. Okay. So two pixels are connected if they are neighbors adjacent in some sense. Okay, and some predefined criteria is satisfied. Okay, I repeat again, some predefined criteria is satisfied. So, or what is mentioned here, their gray level satisfies a specified criterion for similarity. Example, equality. So we'll see this. Okay, you can have different constraint or different conditions for this. Okay, so right now you just try to understand that even if two pixels are adjacent to each other and if they don't satisfy the criteria of similarity, then you cannot say they are connected to each other. Okay, I repeat again, even if two pixels are adjacent to each other, okay, you cannot say they are connected if they are not satisfying the similarity criteria. Okay, so in a binary image with values 0 and 1, okay, binary, what is the meaning of binary image? Either it will have a value 0 or 1. Two pixels may be four neighbors, but they are said to be connected only if they have same value. Means if I have two pixels P and Q, okay, they are neighbors, okay, neighbors, but if this has a value 1 and this has a value 0, then we cannot say that P and Q are connected. Okay, so V is a set of gray level values used to define adjacency. So V is a set which will define the criteria of the similarity. Okay, so V is, what is the meaning of V set of 1? It's an example. V is the set of pixels having value equal to 1. That is the predefined criteria for adjacency. Okay, so the pixels which are physically adjacent to each other and satisfying the set of V, we can say that they are connected pixels. Okay, now there are three types of adjacencies. Okay, very important, they generally ask definition in the exam. So there are three definitions you have to remember: 4 adjacency, 8 adjacency, and M adjacency. Okay, so what is the meaning of 4? 4 adjacency is related to 4 neighbors, 8 adjacency is related to 8 neighbors, and M adjacency means mixed adjacency. So it's a combination of 4 and 8. So now, okay, now two pixels P and Q, two pixels P and Q with values from set of V are adjacent if Q is in set of N4P. Means if there is a, what I said, see, V is a set of suppose 0. Okay, and what we have to check whether Q is 4 adjacent to P or not, whether there is adjacency, 4 adjacency. So first thing what we have to check whether Q is in N4P, means whether Q is in this set, either vertical neighbor or horizontal neighbor of pixel P, and it satisfies the criteria here. So if both the values are 0 and Q is in N4P, then only we can say that Q is connected to P and it has a 4 adjacency. Okay. Now for 8 adjacency, what we have to check? Instead of N4, we are going to check whether it is in N8 of P. So this is your P and this is your Q. Okay. First thing what I have to check, whether it is in N8. Okay, whether it is in Q is, suppose Q is here, okay, suppose Q is here. First thing I have to check whether Q is in N8P, whether it is in the set of 8 neighbors of P and also satisfies the criteria of P. Then only we can say that two pixels P and Q are 8 adjacent. Okay. The third adjacency is M adjacency, that is called as mixed adjacency. Now, what we say here, two pixels P and Q with values from M are M adjacent if Q is in N4P. Okay, if Q is in N4P. So, if Q is in N4P and satisfy V, then we can say it's M adjacent. Okay, or means if this condition is not satisfied, if P is not in N4P, then only you are going to check this condition. Okay, so what the next condition says, whether Q is in NDP, means whether Q is in a Q is a diagonal neighbor of P, and okay, and means both the conditions should be satisfied, this and this, and the set of N4P and set of N4Q, the intersection, okay, has no pixels with values from V. So there is nothing common between N4P and N4Q. Okay, so these two conditions should be satisfied. Along with this, it should satisfy the set of V, then only we can say it's a mixed adjacency. Now the example for this is, suppose this is your P, these are the pixels. I'll draw this first. So if this is P, okay, if this is P and this is Q, okay, and V is set of 1, suppose, okay, and this is 1, this is 1, this is 0, this is 0. Now first condition is what? Q is in N4P. Is it satisfied first condition? No. Why? Because Q is not in N4P. Okay. So we'll go for the next condition. What is this? Q is in NDP. Is it true? Yes, because it's diagonal neighbor of P. So this first condition is satisfied. And N4P. What is N4P? The 4 neighbors of P. 1. I'll take some other color. So this is 1, 2, 3, 4. These are N4P. And what is N4Q now? What is N4Q? 1, 2, somewhere down, and this fourth one. Okay. So nothing should be common. So even if these two pixels are common, it is not satisfying the set of V. So this condition becomes true, right? So then we cannot connect this way. We cannot connect this way or this way. We have to connect this way. This is called as M adjacency. Understood? Okay. If you have any doubt, you can we can solve it during question answer session. So mixed adjacency is a modification of 8 adjacency and is used to eliminate the multiple path connections that often arise from 8 adjacency. Okay, so here you can see this is set of V and set of V is suppose 1. So you have to connect like this, right? All the paths are possible. So there are multiple paths, and here since this is not satisfying the set of V, so you cannot connect like this. You have to connect like this. You cannot go like this, right? You cannot connect, so you have to go like this. You cannot connect like this also because this is not in set of V. Okay, so two image subsets S1 and S2 are adjacent if some pixel in S1 is adjacent to some pixel in S2. This is very natural, right? Very easy. Now what is boundary? Okay, what is the difference between boundary and edge? Let R be a subset of pixels in an image. R is a region if R is connected set. Means if this is the image, okay, and if this is the region. Okay, so region means what? It should satisfy all the pixels within the region should satisfy the connectivity. Okay, connectivity condition. It should be it should satisfy some similarity criteria. Okay, its boundary or border or contour is a set of pixels in R that have at least one neighbor not in R. So what I said before, if you take any pixel here, okay, any pixel here, at least one neighbor of this pixel will be outside the region. Okay, if R is an entire image, then its boundary is the set of pixels in the first row, first column, last column. Understood? So if this is the image and if I am talking about this boundary, so obviously what? Then its boundary is the set of pixels in the first row, last row, and first column and last column. Okay. So boundary is a global concept. Okay. Like when you see Earth from space, you can perceive that as a sphere because you will be able to see that entire object. So you can say that it's a boundary. But when you are part of the Earth, okay, okay, you cannot say it's a boundary, right? So boundary is a global concept and age is a local concept. Okay, so as I said, boundary is a global concept and it is a closed path. Okay, so boundary, if this is a region, the boundary is a closed path always. And what is age? Age is a local concept. So suppose this is image having black and white area. Okay, this entire thing is black and this is white. So okay, here there is no line or edge which is physically present over there, but since there is a sudden change from black to white, we perceive this as an edge. Okay, similarly for this area, if this is a white area and if you have a black pixel or black point here, so this is again a gray level discontinuity, right? There is a sudden change from white to black. So age is a local concept that is based on a measure of gray level discontinuity at a point. So gray level is also known as intensity. So intensity or gray level discontinuity. Now, next subtopic is distance measure. If you want to measure distance between two pixels, okay, there are different ways to measure the distance, and the application may be one of the application may be like in Google Map. If you want to travel from Don Bosco College of Engineering to Panji, okay, if you fire the query in Google Map, you will get shortest path, okay, based on the distance. So how to calculate this type of distance? So there are different measures. Okay. So for pixels p, q, z with coordinates x, y, s, t, and u, v, distance d is a function or a metric if these conditions are true. This you have learned in mathematics also. Okay, the distance between P and Q has to be greater than or equal to 0. Then distance between P and Q is equal to 0 if and only if P is equal to Q, means the starting and ending point is same. Okay, then distance between P and Q is equal to distance between Q and P, and this should be satisfied. The distance between PZ is less than or equal to distance between PQ plus distance between QZ. So this you have learned in maths. Now the first distance metric is Euclidean distance, okay, and it is shown by DE. Okay, this remember. This Euclidean distance between point P and Q. It is a square root of x minus s the whole square plus y minus t the whole square. Okay. For this distance measure, the points having a distance less than or equal to some value r from xy are contained in a disk of radius r, center at xy. So what is this? This is a definition of circle. Okay, so what we say in circle, if there is a center xy, okay, the unit distance from the center gives you a, with radius r, you get a circle. So this is what is mentioned. Mentioned over here. Okay, so it gives a disk or a circle, Euclidean distance. Next is D4. D4 distance is city block distance. In the exam, they may ask you D4 or they may ask you city block. So you should remember the name. Okay. So D4 distance between P and Q, and it is given by this. D4PQ is a mod of x minus s plus y minus t. The pixels having D4 distance from x, y less than or equal to some value r form a diamond center at xy. So when whatever circle definition is there, if you apply it here, you will get a diamond. Okay, so this the circle definition in with respect to Euclidean distance only you will get a circle. Okay, otherwise in D4 or city block distance we will get a diamond. And see here the distance between, see here the distance is unique distance, right? 0 to 1, 0 to 1 here, horizontal, vertical, the distance is same, and we are getting a diamond over there. Next is D8 distance, known as chessboard distance between P and Q, and it is given by this formula. You have to take a mod and then whichever is maximum. Okay, and if you apply the definition of circle here, you will get disk square. Okay, so D4 and D8 distances between P and Q are independent of any path that exists between the points, because these distances involve only the coordinates of the points, regardless of whether a connected path exists between them or not. So suppose this is your P and this is your Q. Okay, whether you have these pixels in between, it will not matter, and it will give you the distance irrespective of other pixels in between. Why? Because if you see the formula, in that you are just considering the coordinates of P and Q. We are not considering any other thing. So that's why we are saying that regardless of whether a connected path exists between them or not. So we are not considering the values or any other criteria for other pixels. We are just taking care, or we are just considering the coordinates of P and Q to calculate D4 and D8 distance. However, for M adjacency, that is DM distance between 2 points, we always consider the shortest path between the points. Okay, so the distance between two pixels will depend on the values of the pixels along the path as well as the values of their neighbors. So in DM distance we are going to consider the neighborhood, but in D4 and D8 we are not considering the neighborhood. Okay, so this example, okay, you see the example. There are how many pixels? 1, 2, 3, 4, 5. 5 pixels. Now what is given? P, P2, P4 has value equal to 1. So P has value 1, P2 has value 1, and P4 is 1. What is P1, P3 can have either 0 or 1. So initially we'll take if only connected, what is written? If only connectivity of pixels valued 1 is allowed, means V is a set of 1, okay, is given. And P1, P3 are 0. Suppose initially P1, P3 is 0. Now the distance between P and P4 we have to calculate, okay? The distance from P to P4 we have to calculate. So what will happen? P1 is in N4P, but can we connect? No, because it is not satisfying the criteria of V, right? So we have to connect like this. What about this P2, P3? Can we connect? No. So you have to connect from P2 to P4. So this is M adjacency, right? So what is this? This is 1 plus 1, that becomes 2. Okay. Now if either P1 or P3 is 1, so now instead of 0, if P1 is 1, okay, if P1 is 1, so what M adjacent says, if P1 is in N4P, is it in N4P? Yes, and also satisfy the set of V. So we have to connect like this. Again, this is true. Both the values are 1 as well as it is in N4. Okay, 4 neighbor of P. And then like this, because this is 0, right? So 1, 2 and 3. So what is the distance? 3. Now, what is the next condition? If both P1, P3 are 1, so instead of 0, I have this 1. Okay. So what will happen now? This is true. Yes, I can connect like this. Then I can connect like this. Then can I connect like this? Yes, you have to, right? First condition of M adjacency, that is true. So we are not going for the next condition. And then this is true. So this is 1, 2, 3 and 4. I am getting 4. So what I said, for M adjacency, we consider the neighborhood and we'll get different cost for each path. And then you can select the minimum cost path. Next is image operations on a pixel basis. Okay, operations between images such as dividing one image by another. Okay, so what we are going to do here is, suppose there are two matrices. Okay, suppose this is 3 by 3 and this is also 3 by 3. If I want to divide one matrix by another matrix, directly we cannot do it, so we have to do pixel by pixel. So you can divide this value by this value and write into a new matrix. Okay, similarly you will do for all nine pixels, right? So dividing one image by another image, you are going to divide one pixel by another pixel and writing it into a new matrix for some application. Okay, other arithmetic and logical operations are also possible using matrices. Okay, whatever knowledge you have for matrices, you can apply for the images, because image is a matrix. So image is represented by a matrix and matrix division is not defined. That's what I told you. So you are going to divide pixel wise. Okay, pixel to pixel. That is what is written here. The first element of the new image will be equal to the first pixel of original image F and the first pixel of the second image. Okay. Now what are linear and non-linear operations? H is an operator whose input and output are images. So H is any operation. Okay. So H is said to be a linear operator if for any two images this condition is satisfied. So what is this? A and B are scalar values, any constant, and F and G are the images. Okay, these are images and these are the scalar constant, and this is the operation. Okay, any operation. So what we are saying, if this left hand side is equal to right hand side, then only we can say that H is a linear operation. Okay, so you can multiply the image matrix by a constant first, then add 2 and then apply the operation, um, or what you will do, first you multiply the constant, first you apply the operation, then multiply by a constant and then add. So both the things will be same, then only we can say that H is a linear operation. And whenever this is not true, okay, whenever this is not equal to left hand is the left hand LHS is not equal to RHS, then we can say that H is a non-linear operation. Okay, the result of applying a linear operator to the sum of two images is identical to applying the operator to the images individually, multiplying the result by the constant and then adding the result. So that's what I explained you just now. Okay, and as I said, when this condition is not true, then H is called as a non-linear operator. So linear operators are exceptionally important in image processing because they are based on significant body of well understood theoretical and practical results. So we will see these linear and non-linear operations later on, okay, in next topic or next unit, you can say.